Live from New York, it's Ask an Engineer.
Hello everybody, welcome to another fabulous Ask an Engineer. We're broadcasting live again from the Adafruit downtown secret headquarters. I'm Lady Ada. I'm turning off the lights. Also with me is Kate, the Hartman,
Yeah.
who's wearing a neon yellow jacket. This is like the first time a neon yellow jacket has appeared on the show.
Yeah, we have a strict dress code here.
Yeah.
Oh, should I?
You're wearing all black. That's okay, because now people can tell who you are. Good. See, you did dress well. You're just ready for any occasion.
Yeah.
And we're having an exciting show,
That's right.
including our special guest. All sorts of cool videos, images, blinky stuff. Tell them what's on tonight's show, Adabot.
Okay, on tonight's show, we'll be talking to Kate. She's visiting. She's going to be here for the first 15 minutes, so we're going to go through some of her past projects, what she's up to, and a bunch of stuff, and then she is going to leave on to the next video show. No, I don't know.
She's got to go on to the Tonight Show.
Yeah, we're going to talk about our show and tell that we had tonight, some fantastic stuff. Some news around the web, some new exciting things being launched, released, places that Lady Ada will be, things on our new site, items that are back in stock, Raspberry Pi tutorials that we're releasing, Ask an Educator things, requirements, certifications, badges,
Things.
mailbag,
Things.
a new tutorial,
Things.
a video from Becky Stern, some new products, from screwdrivers for iPhones and iGadgets to waterproof boxes for Arduinos and things that fit inside of boxes, LEDs, matrices,
Current sensors.
We'll have a top secret project. We'll answer your questions. We'll have trivia questions. We'll have a cat. All that and more on Ask an Engineer.
Jam-packed show.
Yeah. Whew,
We still
okay.
need a theme song.
Yeah.
Yeah.
You know, sometimes I can just go through them, and then sometimes I stumble. There's too many things on the screen.
I know, you're just...
Yeah. Okay, we got to start this interview. We
I
got to do
know.
it right away.
Okay.
One little order of business. Tonight's code is Turing in honor of Alan Turing. 10% off many things in the Adafruit store. It's his birthday, Alan Turing.
We should,
We'll talk about
if we had the time, we could have done a thing where it's like 10% off everything in the store that's Turing complete, but there's actually not that many items that are Turing complete in the store.
You could talk about that.
Okay.
Because that always comes up in like open source arguments, and then you throw down the Turing complete thing, and then people back off.
Yeah, you should have told me, well, there's only 3 items. People would have complained. They'd be like, I want all these other things on sale. We'd be like, well, there's only 3 Turing complete items in the store.
Yeah.
And that would have been a downer. But anyways,
Okay.
that's our code for tonight, Turing. Get 10% off.
All right.
Use it and try out the 14th Street, because that was and it's part of NYU.
Yeah.
And what are you doing there?
I am directing this summer program called ITP Camp. So ITP is a 2-year grad program where people make crazy things with technology.
And you went there.
I went there, yeah.
And then you taught there.
I did,
Okay.
yeah.
So now you're back.
I'm kind of an ITP junkie.
Okay.
Yeah, so whatever.
Did your parents say, like, are you doing the ITP?
Yeah,
Okay,
okay, no, you're here again.
Okay, so you're teaching this, like, summer camps for high school kids or college kids?
It's for grown-ups. It's actually summer camp for grown-ups.
Okay, grown-ups, like graduated from school and then they want to do more creative stuff?
Yeah.
So, like, business people or, like...
all kinds of people.
Okay,
So
people,
business
okay.
people and artists and, whatever. People, who write for newspapers and people who just want to make things.
Okay.
But the problem with ITP is it's 2 years, it's grad school, it's really expensive. So we wanted to...
I just want to get that all done in, like, 3 weeks.
Yeah, exactly.
Okay.
So it's like you take, classic ITP and you put it in a blender and then you put it upside down.
Okay.
So, anyway. But yeah, we've got lots of stuff, programming classes, hardware.
So you teach, like, an
Microbots.
intensive 8-hour thing? Or what is it?
It runs all nights and weekends. So
Okay,
it's
wow.
meant for people who have day jobs if they want to...
And what in particular are you teaching? Are you teaching one class?
I don't teach it, I organize it.
Okay, you're organizing it.
Yeah.
Sorry.
Yeah. So like
Your management.
yeah. Well, I teach a little bit too. I mean, I teach like physical computing and wearables, but we've got people coming from kind of all necks of the woods.
Okay.
Probably about 50 different
And
people
then
teaching.
next year it'll be running?
Yeah, yeah.
Okay, so anyone who's in the New York area can sign up. And take it
Yeah.
next year.
And-
Okay, good.
or if you want to come into town for it.
Oh yeah, of course. I'm saying if they can come into town in
Yeah,
New York.
yeah.
Okay, that sounds great.
So they find out more, itp.nyu.edu?
/camp.
Camp.
Yeah.
Okay.
Okay.
Or just Google for ITP camp. Okay.
Well,
next up, let's
yeah.
do the
Well-
retrospective.
Well,
Oh.
yeah, there's 2 things. I would
Oh.
say you're probably known for botanicals, which a lot of people might
Yeah.
remember. So do you want to talk about the botanical project
Sure.
a little bit?
Yeah.
Talk
You
about your history. Okay, so this is a phone and a plant. Is that your hand?
That's Not my hands.
Okay.
That's my.
So you were an ITP and you were a grad student.
Yeah.
And they were all like, you need to have a final project.
Yeah.
And you're all like, oh man.
Yeah.
And then you're all like,
and we were like, screw technology, we want plants.
okay.
And so then we got a bunch of plants, and then we're like, oh, we forgot to water them.
And they all died.
They all died. And so
Okay.
then we were like, we have to fix this. Let's get some technology. So,
Okay.
But we didn't want it to be, like, everyone asked us why we didn't just make an automatic watering system, but we wanted people to actually attend to the plants.
No, you don't want to have a pet. There's no point in having a pet if somebody else is petting the pet, feeding the pet, watering the pet. It's like, what's the point? You want to actually have some interaction with this pet or the animal or this plant.
Yeah.
So you created a semi-automated plant
Wait, let's back
phone
up.
system. Wait,
There's two separate projects. Tell about the installation project
Okay, so
first.
the first-
You better tell about that one.
Sorry, Botanicals won.
Botanicals won. So Botanicals classic.
Classic.
So we were like, okay, well, sometimes when people need things, they call each other on the phone, and so we're like, okay, why can't the plants just make a phone call? So we made a sensor network in the lounge at ITP, and we hooked up all the plants so that they could call the sort of public phone that was there when they needed to be watered.
So you'd be sitting there, you'd be like typing, doing your homework, and the phone would ring, and you pick it up, and it would say,
It would say, hi, it's the pothos plants. Can you water me? Like,
Okay.
kind of thirsty.
And if I recall correctly, some of the plants had accents based on where they were in the world. Okay.
Yeah, so they had different voices based on their botanical characteristics.
okay, so what kind of system did you use for this? What was the underlying phone stuff?
It was Asterisk.
Asterisk.
Yeah.
Okay, because this was back when Asterisk was like the hip new thing. Now everyone uses like Twilo or something or whatever.
Twilio, yeah.
Twilio. I don't know. How to
Yeah,
pronounce
it's a lot easier now.
And
But,
then this went off to the MoMA, right?
The next version did.
The next version. Okay.
Yeah.
Okay.
I'm skipping ahead.
it.
Yeah.
Botanicals 2.
Botanicals 2.
Okay.
So then we were like, oh, so then, people liked it. They were like, oh, that's kind of funny and weird, and I want my plants to talk. And so then, we thought about making a kit, and that's actually when we talked to you guys. And so we, for a while we were working with different shields, and then eventually we made this leaf-shaped circuit board. And rather than having people running their own Asterisk servers, we thought, maybe have something that was a little bit easier. And so we ended up working with the Twitter API. And so we made it so that your plants could tweet.
Yes.
And this was kind of
Which you can do
interesting.
to SMS, which is basically the same thing. Like it's
Yeah.
your cell phone, so
Yeah.
you know, 'cause you don't wanna,
That's why we
you don't wanna
liked
use
it.
up your minutes on your
No.
Because it was a
plans.
great SMS free gateway.
Yeah, exactly.
Yeah.
Yeah, but the interesting side effect that we didn't really think through was, lots of people could be following a single plant. So all of a sudden my plant had like 3,000 followers.
Okay.
So
you found
that was a weird dynamic.
So it was kind of like Kate, water me.
Yeah.
Kate,
and then my friends would be
water
like, why are
me.
you such a
Your
jerk?
your
Kate,
plan.
water me.
Yeah.
And everyone's like retweeting. It's like this poor plant's being massacred
Yeah, yeah.
by Kate. Okay, so that was kind of.
And so then
so this went to MoMA.
this went off to the MoMA.
Yeah, this went to the moment. So last summer last spring we got a call and it was like, oh, we'd like to put this in the show at the MoMA. And we're like,
Yeah.
really?
Yeah, I think I saw that show.
Yeah,
right. That was
Talk
the
to Me.
Talk to
Yeah.
Me. So it was a lot of like interactive art stuff. MoMA went through this like weird like 2-year phase where they were like crazy about interactive art, which is cool for everybody we know because
Yeah.
everyone became an artist because they had their stuff in
A
the
quick
museum.
question,
Yeah.
because I know this project was a while ago. If you could do it over, would you do power over Ethernet? So you
Yeah.
can have
Yes.
Okay. And is this
Or-
and this
well,
is
now we have power over their cables that are like really.
and this is
big
an open
yet.
source kit. Couldn't someone make improvements?
Yeah, they should.
They could.
Yeah, it's
They
all
should.
the files are online. So.
And then last up, I remember when you were doing this, this wasn't called Internet of Things.
No.
But this is now.
Yeah.
Someone would say, "Oh, that's an Internet of Things
Exactly. Yeah.
project."
Yeah.
And it's not fair to call it a thing because it's a plant.
No.
So you're still maybe in your
And
own.
who cares about things?
Yeah, you're still in your own like world. It's Internet of plants or
Things
something.
that connect to things that are alive.
And then next up, I think a lot of people have probably seen the TED Talks, and this was, I think, one of the stills from it that I grabbed. Can you
that's
talk a
me.
little bit about these hats and stuff that you did?
I make these hats. I don't know.
Are those knitted hats?
No, they're fleece. They're
Okay.
sewn. But
Okay.
And they're
so
filled with electronics. What are in them?
well,
or
you
some
know,
of them are.
What's
I
up
make-
with this left hat? What's going on with this the blue
That's
hat?
the muttering hat.
Okay.
I make a lot of stuff with technology, and then I make things that are kind of about ideas of how I think technology might work.
Okay,
and
so
the,
you got this
the
hat.
muttering hat's about liberating the voices in your head.
Oh, so
So
they
that-
speak directly to you.
Yeah, but
Okay.
then you can detach them and you can like,
Oh.
let other people listen.
Okay,
Yeah, so
that's cool. And then what's the second thing? It's a heart.
It's a heart. It's an inflatable heart, so you can use it as a tool in communication. So
And then the green one.
gut listener.
Okay.
Yeah. And
Yeah,
then the one-
rumbling.
Yeah,
Okay.
so you can, kind of reconnect.
Okay, and then what's the white one? Oh,
The white one is, it is the Talk to Yourself hat.
Okay.
So.
And is this part of a different range of projects? Is this part-
Yeah.
Okay.
Yeah. I mean, this is kind of, I guess, this is more my, art practice.
Okay,
But,
so in Toronto, you're in Toronto now.
Yeah.
So in Toronto, are you still teaching? Or
Yeah,
you...
I'm an assistant professor at the Ontario College of Art and Design.
Oh, okay, cool. So you've got like minions and stuff.
I do, yeah. And we're starting all these cool new programs. We just launched a new grad program this year.
And so you're teaching like physical computing stuff, and you use Arduinos and sensors.
Yeah, all
and
kinds
these
of
are
stuff.
like classically trained artists, like painters
Artists
and stuff.
and designers, yeah.
Do they want to learn this stuff, or are they like, we need to learn this stuff, or like is this all alien to them? How do they approach it?
In different ways. Like now that we've got these new programs, people are coming specifically to do this stuff. But I also teach a lot of wearable electronics there, and so I get people who are coming from textiles programs, from the jewelry program, from industrial design, and then I hand them, an Arduino and some sensors, and I'm like, see what you can do with this. How can you incorporate this into clothing? And it's crazy what they come up with.
Yeah, that's cool, because they're not trapped by the same stuff that
No.
we are. Like, we've seen the same stuff over and over again,
Yeah,
so it's like,
they're super fresh.
yeah, that's cool.
What are some of the trends you see? Because like ITP was, because I'm in New York, I go to the show every year,
Yeah.
and like 1 year it was all the Wiimote stuff,
Yeah.
and then it was Nokia phones, and then it was iPhones, and then
It was Connect.
and then it was Kinect stuff.
Yeah.
What trends are you seeing in Toronto that are kind of sweeping
Yeah.
through your classes?
Well, it's interesting because I work with these different populations of students, and then they all, get together in my class and influence each other. But like with the industrial designers, they all want to solve the world's problems. They're like,
Yeah.
how do I, make a hockey helmet that detects concussions? Or
Yeah.
like,
I was
how
going to
do
ask, is there like hockey projects because you're in Canada? But I was like, oh, people are going to get
can't
really
ask,
angry
yeah.
at me because I'm going to be like, not all Canadians are into hockey. But then, like,
The first sample
you
price.
go ahead and you just say it. Okay.
Well, yeah.
But so they're really interested in like using the technology for social purpose.
Yeah, and then with the textile students, they're really into materials, right? And
Yeah.
so just like everything that's coming out of the kind of make craft community with working with like felting, making conductive felt sensors, and actually
Yeah.
like weaving. There's a lot of expert weavers there. So weaving.
So that's
and-
cool. Yeah. I mean, like that. I mean, we have this really nice like stainless thread, and
Yeah.
you can actually weave it in. And the nice thing about it is because it's stainless, you can wash it and wear it, and
Exactly.
it's solid.
Yeah.
It doesn't flake or anything.
Yeah.
So we were thinking it'd be cool if you could, you could do cool stuff with looms to create like antennas and meshes and grids and
Absolutely,
stuff.
yeah.
So
Yeah,
that's
so
really
they're
cool
great
stuff.
at
So
that
we'll
sort of
see
thing.
that eventually. We'll eventually see personal area network
Yeah,
stuff where it's
exactly.
like I have sensors and like my shirt is the antenna.
Right.
Which is cool.
Yeah. Totally.
Or it's interesting. Like your soil sensors for the botanicals is just 2 pieces of metal.
Right.
So you could build that into clothing too.
Totally.
So,
Yeah.
not as if you were a plant, but like to measure like how much you're sweating, which can tell you a lot about how healthy a person is,
Right.
and if they're overheating or dehydrating. Okay.
Okay, where can everybody find more information about you and what you're up to?
KateHartman.com.
Yeah, I posted the link. I know, that was a loaded question.
Yeah.
Okay, we promised we.
Do you want to also say what the school program is? People want to get
Yeah,
check it
yeah.
out?
So if
Yeah.
you just go to ocadu.ca, that's where I teach.
Okay.
And
Okay.
the new program is called the Digital Futures Program.
Digital
Fantastic.
futures.
Yeah, and we also have an undergraduate minor in wearable technology.
Oh wow!
Okay.
Yeah,
Is this the first place?
I think it's the first.
I've never heard of this. That's
Yeah.
really cool.
Oh, great. So, just to pre-announce, you're going to have a Flora when we start getting these out there. So
Yay!
now we
Super
now we
exciting.
absolutely have to give you one.
Now I really
Yeah.
have to.
That wasn't
finish.
just a before show nicety thing.
I have to finish this project.
Yeah. Okay. Well, we promise we'd get you out of here in 15 minutes.
Okay.
It's
so thank you
exactly
so much.
15 minutes.
You guys are awesome.
All right. Well, thank you for being part of
Thanks
Show and
for
Tell.
having me. Yeah.
Thanks for
And
visiting.
we're going to be visiting Toronto to see Mike, who worked with
Yeah.
us on our project.
Yeah,
Okay, great.
Okay, well, see you soon.
All right.
Bye,
Okay.
Kate.
It's nice to see you again.
They're gonna go.
Nice to meet you. All right.
They're gonna go party in the night, and
Yeah.
we're gonna stay here.
We're just the first stop.
They're gonna go drinking,
If you do,
partying.
take care. If you do wearable electronics now, you're invited to all the cool parties.
That is true.
Yeah. All right.
Okay. We have to finish it so we can get invited to these cool parties.
Everyone says bye to Kate on the show. too.
Okay.
All right. So let's get back to the show here. Turing is the
Turing.
code. 10% off. Many
Sure,
things in the
many
Adafruit
things.
store. All right. We're just gonna grind through this.
Okay, so we're gonna talk about the show. And
Yeah,
tell.
we're gonna go to the show and tell. If you go to the Adafruit YouTube, you can see the recorded
It's probably
one.
already up.
Probably already up after the show. Check it out. On the show and tell this week, we had Chris, who showed his work desk
Yeah,
with all his LEDs and his living room.
Has a nice workbench.
And
he
did something interesting that he's trying out. So he's colorblind, and he has RGB LEDs, and he's turning the colors on at different times. So he can turn it on red, and something disappears when it's red, or if it's blue.
It turns black.
It turns black.
If it's blue light, or if it's red.
Very cool idea.
Blue light, because it doesn't reflect off.
Yeah.
Color theory. We had Chase, and he had a TBB Gone jacket that he modeled after Becky's.
That's right.
Super cool. And he's going to go and test it.
Yep. And then Taylor had the Haunt box, which is this really cool Arduino with a relay.
It's a Halloween. It's basically.
It's Ethernet, Arduino, and like a relay.
It's
stuff.
Ethernet, Arduino, like power FETs.
Yeah.
And a wing shield, a screw shield, basically, all rolled into one. And so they're going to try to get into manufacture, and they're starting at the right time, but they really have to.
Yeah. They got a Kickstarter.
They have a Kickstarter. They have to get this going because it takes a really long time to manufacture.
It's a really cool design, and Halloween is our favorite holiday. We're gonna have a big announcement about some Halloween stuff that we're doing.
I'm gonna design something for Halloween too.
Yeah, Halloween is fantastic because everyone can participate. There's costuming, there's electronics.
Yeah.
It's my favorite holiday when I write about electronics and making things, and it's also one of the fun ones to go out in the world and see because anyone can buy a costume, but the people who make their costumes, those are the ones who always, I think, win and get the prizes, and everyone's like, oh, you made that. Wow, that's so cool.
Yeah, cool.
All right. And then Ben had this really cool alarm clock mod. It was fantastic. He didn't want the little tiny buttons because he couldn't hit it, and he showed using our arcade buttons how to
the basic
modify
but very effective hack.
Yeah, I thought it was neat because alarm clocks, everyone hates them, but if they could just change them a little bit, they would.
Well, it's interesting because he said like his alarm off button was like really teeny, and it's like you want to have a big snooze button so you can whack it. And then I think about the arcade buttons, you can hit them as hard as you want.
Yeah,
they're meant to be
smacked
as hard as possible because it's arcade buttons.
It would be cool to have an alarm clock that doesn't stop unless you do a certain like Street Fighter command or something like that. Yeah, ooh, that's good.
Hadouken!
Yeah, I'll start. That's my Kickstarter, the arcade alarm clock. No, okay. So how do they get on the show and tell?
Getting the show and tell is super easy. Just go to my personal, the More Freed Lady Ada Google Plus page, and I post up once in a while and say, respond here if you want to get added to the show and tell circle. And if you respond, I will add you to the show and tell circle, and then you will get notified when we have the show and tell. Do it before the show and tell, because 5 minutes before the show and tell, we're busy getting ready for the show.
Okay, so since we had Kate do the interview, we're going to go through the news items extremely fast because they're all on our blog. And you can check them out, but we're just going to go through these really fast.
Okay, for sure.
So first up, big news. Propeller has a
GCC
beta. Why is this important?
Okay, first off, this is cool because it means it's turn complete. No, just kidding. Second up, you can write code for your propeller using C and probably C++ if they...
Yes.
They ported both C and C++ parts. So you can actually code your propeller, which I'm sure you love, but you may not be a big fan of spin because I've never met a big fan of spin. So you can now write your code in C or C++, which makes it a lot easier to read, a lot easier code. It means you can have more than 6 nested ifs. Chip, why'd you do that? Check it out. It's cool. It's open source. It's an awesome way to write code for your propeller chip on any platform. What
I really like is Parallax is responsive. This is something people ask for and they deliver. Very cool. Okay. Next up, and we're not going to spend a lot of time on this, but we did want to mention it. So, Freescale has a $13 ARM board. It looks a little bit like the BeagleBone, and it's also Shield compatible as far as the headers go. And this just reminds me of the trend, which is now that the Arduino has kind of popularized the idea of doing electronics. One of the things it did, when these big companies come out with their own low-cost platforms, they make it so Arduino shields can fit on it. Even though that makes absolutely no sense in this case, because there is no Arduino IDE that is compatible. They're probably not even going to release a cross-compatible open source IDE. Yeah. I don't believe there is one for this Freescale chip. I like that it's $13. I mean, a lot of people are going to play around with it. We'll see how it goes. Well, the guys who did the BeagleBone said, "Hey, we were thinking of making it Arduino Shield compatible." I said, "Please don't, because it doesn't make any sense, and you're just going to cause everybody a lot of headache because people will say, well, I bought your motor shield. Why doesn't it work with a BeagleBone?" It's like, well, because none of the pins are compatible. Like it's completely separate and different and weird. It worked out great for BeagleBone. It's its own platform that has its own. The Raspberry Pi is an Arduino compatible. Yeah. Either.
And
Anyways.
that's good. It shouldn't be. I mean, there's a reason why the Arduino is that way. It's like you should only have stuff that's Arduino compatible be Arduino compatible.
That's
my
right.
opinion.
And if you're going to do something that's Arduino compatible and you're a big company, invest in doing libraries and things. Don't just say, hey, the community will do it for free.
Yeah.
Maybe put some resources behind it and at least have some samples and.
Well, that's funny because it makes it seem like Freescale's probably like, oh, well, all I have to do is like make the header pins on the spacing and then like the problem is solved, you know, which is not, you know, and the shape, form factor of the Arduino is the least important part of the Arduino.
Yeah. There's an article about all this.
That you wrote. Okay, great.
Okay, next up.
A fluke cake.
Yeah, this was on Dave Jones' blog. By the way, the
microcurrents.
The microcurrents are back in stock from Dave. We're selling them in the US.
We sold them out. Like
yeah, they're really popular. But this was on his blog. This is a fluke cake next to a real fluke. Really cool. Check it out. Next up, Lane's PCB service that was part of Dorkbot PDX is now
his own thing.
OH.
Open Source Hardware Park.
Yeah.
Not sure what exactly the park stands for, but maybe it's
a park. Like, yeah, it's so much fun.
Anyways, so I'm just going to keep calling it Lane's PCB service.
So Lane's PCB service is those purple boards you see everywhere. It's fantastic. John Janier and myself are doing an interview with him that'll be on Make hopefully soon, and talking about the launch of this new business, why he's like managed to figure out what no one else could for makers, how to do great PCBs for makers.
Sweet.
And he
check it out.
And people who met him in person, he actually has purple glasses. It's cool. Okay, next up, there's a Python library, speaking of BeagleBone, for the BeagleBone, for the thermal printer that we saw.
Yeah, people love using the thermal printer with the BeagleBone. Matt Richardson started out the porting, and then somebody else finished it, and they made a nice Python library.
Yeah.
And I'm excited to see that for stuff like BeagleBone and Raspberry Pi, because they're computers, it doesn't necessarily make sense to have an IDE like Arduino, because it's not a microcontroller, it's a computer, and so despite all of them being Turing compatible, the Raspberry Pi and the BeagleBone can run Python because they just have much more RAM and processing space. But, more Turing complete facts, if the Arduino had more RAM and processing space, there was no program that it could not run that the BeagleBone runs.
Yeah, we just run it slow, but...
It would run it very slowly, but it could run any program because it has the same... basically they're both Turing complete. So any Turing complete program can run on both, which is awesome, which means that you can always port your libraries from an Arduino to BeagleBone or Raspberry Pi.
One thing, so when people get on mailing lists about open source hardware, sometimes there's arguments about, well, it uses a chip that's not open source. And the thing is, an Arduino doesn't need that chip. It can use a different chip.
It is abstracted, yeah.
Yeah, and that's one of the things that, as long as it's, and I've seen you talk to people about this, as long as it's Turing complete, we're okay. And so,
well, a lot of people would say, like, well, the AVR is not open source, and so the Arduino is an open source. And basically my response would be like, well, but the AVR is documented well enough, and because all processors are basically Turing complete, and it's basically just various add-ons like ADCs or DACs or I2C that are built in. It doesn't matter because the software an Arduino sketch can be rewritten since it's all Turing complete. Can be rewritten for any other device. Like you can run any Arduino program on a BeagleBone. You just have to change the pins around, and so you can design an AVR chip in FPGA. There's nothing magical about it that you can't emulate in FPGA. And so somebody I think even made an AVR chip with an FPGA. Now it costs like $80. It's a pain in the ass. It runs really hot, and it's like huge. Yeah. But you could do it. So there's nothing about it that I agree that it's not open source all the way down to the metal. Yeah. But luckily, that's not so important because what we are talking about is on a layer of abstraction. Just like we can have open source software, and it doesn't have to run on open source operating systems.
Yeah, like an Intel chip isn't open.
Intel chips aren't open, and neither is AMD, but we still have open source software on top of it.
Okay, next up, you're speaking at the Rockefeller Foundation on Tuesday. Big deal. You're going to be talking about how open source software and hardware is potentially good for the world.
We're going to record it, or what's the deal?
To
record it?
Yeah, so I'm going to be there, and I'm going to try to record this. And they're
not going to record it.
They said they're going to record it too. And so if they have a better copy than we do, we'll use theirs.
Okay.
And we'll try to get it out to everyone. So you're speaking, Bree. A fellow named Mark Post. He does the No Kill Meat. And Carlo Raddy, director of MIT Sensible City Laboratory.
What's funny is like we now only see Bree when we both go to events together and we're speaking.
That's right. Okay, I'm going to keep moving on to this news. Please vote on the Lego section of our site. It's adafruit.com/Lego.
For the hackerspace Lego.
Yeah, if we get just
8,000 more votes.
8,000 something more votes, Lego will probably make a hackerspace filled with a Lady Ada with a laser cutter, a MOSFET cat, a soldering iron, a pick and place. It's all possible. We just need your vote. And so for people who place orders, we also have a little postcard that we're putting in to remind people to vote. Okay, next up, we have a new 404 page that's actually not up. We have to fix this.
Well, we're moving the server and stuff, so that's why everything's kind of a mess. And we'll be showing, maybe not this week, but next week, we'll be showing why we had to move servers and all the downtime we've had recently.
We'll have some
while we're upgrading.
Cool stuff. Next up, back in stock, the Mesograph pens.
Yep.
We just got those in. We started a new segment, Pi Days. Friday Pi Days.
Friday Pi Day.
So our friend Mikey wrote on a great article on our site on how to use our SD cards that we sell and put the Linux OS that you need to run the Raspberry Pi.
When you get a Raspberry Pi, it comes with nothing, so you actually have to, you can't just turn it on, it won't work. You have to get an SD card and you have to burn the image on.
Yeah.
So he shows you how to do that using a Mac.
Yeah. And for Windows, there's like a tool that works.
There's a tool, but
good. And then
for Mac it's a little tougher, I think.
Yeah.
So that's why it was good that he did that one.
Okay, so now you know how to do that, and we'll have a whole series of Raspberry Pi tutorials that are going along with our new products, and we'll have some awesome Raspberry Pi announcements soon too that we're working on. Next up, a couple things in Ask an Educator. How do I choose resistors to match a multiplex LED matrix? What's the difference between Arduino, Raspberry Pi, BeagleBone, etc.? And Ask an Educator needs more questions. So Adam Kemp is a real-life school teacher. He blogs on our site. He will take your questions. He will answer them in context for educators, so you can help students or people that you're teaching as well. He also wrote up two requirements documents, and these are documents that you can use to give students, give anyone you're teaching a test, and in the end you can award them. So we have exercises that they can do to learn the metric system, and at the end you get a metric badge. Soldering exercises. Here's the thing that you need to learn to do to get a soldering badge. So
that's cool.
Yeah, the Girl Scouts do not have a metric or a soldering badge. I think the Boy Scouts might have one, not a metric. So these are the little things that we're doing.
Metric.
You know what? It was interesting. When I was a kid, they were all trying to get us to metric, and it was like a failed effort. They kind of
there was this little bit of a push where they're like, no, really. But then you go into the industry, and all of industry is still imperial.
So we kind of have to. Maybe if kids will learn a badge, they'll do it. I don't know. Anyways,
I don't know. I really like imperial. I'm not the only person who. I'm just completely honest with the fact that I really like imperial. I really do.
Yeah.
Like, because I do PCB layout, and like, it's actually easier for me to think of tenths of an inch than millimeters, because so many.
It's too late though. You can't, like, kids learning now. If they were doing metric, it'd be a lot easier for them.
It's also like there's nothing wrong with measuring. I mean, you can always convert back and forth. There's nothing wrong with measuring.
I think it's tougher in a world market where everyone else uses metric, and like you're always converting. Anyways, mailbag. Here's a mailbag from a fantastic customer, Lady Ada.
That's me.
You need to know that you have unleashed a monster in my 22-year-old daughter. She has become a soldering fool after tackling the Minty Boost. Thank you for your good stuff.
Awesome.
We have
monsters.
Mailbag every Thursday on the site, and it's things that people send in. Okay, next up, you released a new tutorial for a new product that you're going to show. What is this tutorial about?
This tutorial is about the LED matrices. So we have the backpacks, and I just show how to solder the backpacks. Since they come in so many different colors, you have to solder it on. And then how to load the code into Arduino, and just some images of stuff. And
check it out.
Check it out. Please go check out this tutorial and tell us if there's anything wrong with the tutorial page. Okay.
And next up, Becky did a video about our USB microscope that people really like. So we're going to take a quick break and get a
drink some water.
Beverage, and we'll be back in just 1 minute. Here is Becky's video about the USB microscope.
Okay. Go, Becky.
This is the USB microscope from Adafruit. Inside the box, you'll find the main microscope body with one diffuser and a lens cap, an additional diffuser, a stand, a user's manual, and some software, the latest version of which you can download from the Adafruit website. The microscope body clips onto the stand, which can hold it away from the object you wish to magnify. The LEDs are adjustable from very bright to all the way off, and your computer will recognize it as a webcam, so it'll work with all kinds of systems. Here's the inside of one of those old UV erasable microcontrollers. The adjustment dial scrolls between 20 times and 220 times magnification. And unlike a camera, the microscope only has one lens, which means the distance from the object and the magnification multiplier are directly linked. Our favorite thing to do with this microscope is look at surface mount electronics, but I had no trouble finding plenty of other interesting objects to investigate. I can't wait to see the photos and videos you take in the Adafruit Flickr pool. Thanks so much for watching, and don't forget to subscribe to our channel here on YouTube.
Go, Becky.
Okay.
Becky just makes lovely videos.
Yes, she does. Someone wants to know, is there a standard tripod mount on the USB microscope? No.
There isn't, and we're working on getting more mounts or, etc. You can, it is round though, so it's very easy to clamp. So you can use a hose clamp or zip ties.
Yeah.
And you can just hose clamp or zip tie it onto a standard like Manfrotto mount.
Okay. Once again, the code tonight is Turing.
Turing.
10% off many things in the Adafruit store. Turing complete and non-Turing complete.
Yes.
Yeah. All right. Do you know what time it is?
Is it time for new products?
It's new product time. We're going to zip through these too.
Okay.
And we're catching up, and we're going to try to get to these. So it is new product time. New.
Okay, first up is you.
Yeah, first up is me.
You got some to show off.
Yeah, so the Menta now has a nice label on it, and it's available as a separate item. It's only for some of the folks that we're experimenting with for retail. AC Gears in New York City has these, so we're working with them. Make is the other one that has retail versions of our stuff, and you'll see some announcements soon about that, I hope. But anyways, we can go to the overhead, and you can see it's just a little label that we designed. We like it.
Bleep, bleep. Yeah, we're getting these very nice labels made in New Jersey by our favorite label maker.
Yep.
Printing company.
Yep.
So
there it is.
Built-in barcode.
Yeah, and these can be shrink wrapped for retailers specifically for them. And
so the nice thing about
the
nice thing about the Menta is that all the parts can fit in the tin. I mean, this is empty, but all the parts can fit in the tin, and then you put the label on it, and then you're done.
All right. Next up, we branched off into the wonderful world of small tools.
Well, we've actually had a lot of hand tools already.
Yeah.
But the last tool set we put in, they had pentalobe screws in them, and somebody was like, "Oh, are those for iPhones?" And we're like, "Well, let's try." We're like, "Oh, wait, they're not. They're actually like pentalobes for something."
Yeah.
I think they were for old like MacBooks. So we decided to get in a set of tools that will work with iPhones, both new and old, as well as MacBook Airs, and then the new MacBooks as well.
Yeah.
They also use this new pentalobe. So I have these tools, and they're really nice. We actually have a box of all sorts of tools. I can bring it out and show it off eventually.
Yeah.
Maybe at the end.
So these are the different ends.
But we tried a whole bunch of different tools, and we like these. These are they have knurled grips. They're a hardened tool steel. You can use them over and over again. They're pro grade, and they've got a nice balance at the end. They have a rotating cap, so you can hold them straight and twist them. But we found that they're so even if you're dealing with a rusted screw, they can still get it out.
Yeah,
but they're perfect for.
Real quick, I have a fast demo, and this is kind of on. It's part of a bigger project that we're doing. So this is my iPhone, and I didn't like the black backing because it has the Apple logo. I know there's a little bit of thing. Anyways, depending on which iPhone you have, it'll either have the pentalobe or the Phillips. And once you take the two screws out, you can slide the backing off. And once you take the backing off, you can see it's iPhone. Look at the back of it. You wouldn't want to walk around like that. We have these clear cases we're going to be selling soon. And one of the reasons I like these clear cases is because I want to put this RFID tag inside of there. I don't want to put it on the outside because it'll come off. So that'll be a project. I didn't stick it on there. But then we have some other hacks and mods, and also people like to repair these. There's millions of them out there. So we'll have some cool stuff. And we also have some backings that you'll be able to laser etch and do some weird stuff. So anyways, this is the backing of mine. This is a clear backing, and we'll have these, and you can get these screws now. And we have some old Macs here and some new Macs, and we have to repair them and do some weird stuff with them once in a while. So we got these great tools, and as Lamore said, these things spin, and you can open them up pretty fast. So we'll show you how to RFID NFC an iPhone, since Apple's probably never going to have that. Yeah. Anyways. Okay.
Good if you I know in Boston they have an RFID system for the train,
Yeah.
So you could put your pass inside your phone.
Yeah.
And then you can hold it up when necessary because it's a clear back. But then when because it's a monthly pass. But then when you're going through the turnstile, you can put your phone down to go through with your Charlie card.
Okay.
Okay, cool.
Next up, we also we added screws because we were looking around online, and there were like $6 or $7 for 2 screws. So we have a great price. So we're selling them just for a couple bucks because they're hard to get. But
yeah, so these are replacement screws for iPhones.
Yeah.
Either or actually any 4 model. We have them both the original Pentalobe, or you can replace them with the Philips.
Yeah, I like using the
000.
Philips. Okay.
But some people want to have it be like the same. They don't want it to make
Yeah.
it. They don't want anyone to know that maybe they like lost a screw, or they want them to match or something.
Yeah.
I don't know.
Okay. Next up, we have these great waterproof cases that we just released, and for the people who want to know, can an Arduino fit in it? Yes, it can.
Yeah, I have an Arduino.
We have an Arduino already, so let's go to the overhead.
Yeah, so this is just the case, and I like this case because there's a black gasket. You can see this gasket, so it's water. It's actually not waterproof technically because you can't dunk it underwater, but it is weather resistant, so you can put it outside and it'll be fine. It's just not it's not rated for like being dunked underwater for more than like 5 minutes. And there's mounting holes on the back. There's some brass inserts on the inside. We have measurements that Becky made that are really nice. We thought it was cool because you can fit like an Arduino and a shield in it, and then there's a clear top. And then there's these big plastic screws that are actually they're captive, so you can easily screw them in. You can screw them by hand even to get them started. And so it's a clear box, so it's protected, but you can still see any indicator lights. Well, I don't like boxes that are not clear because if you have like an LCD or display inside, you want to be able to see what's going on inside.
So I'm going to show a couple of photos. We have here's the Arduino inside. Here's the back. Becky did a bunch of good measurements. You can see that the
you can fit a
Perma fits in there.
exactly, but you can't fit a half-size breadboard.
Yeah,
so.
and then we have a larger one. This
it's really big.
A lot bigger.
It's so big I can't really show it on the overhead, but it's really big. So we decided to carry like a really massive one for really big projects as well.
Yeah, and like the Arduino enclosure would fit inside that one.
Yeah, you can put this box inside that box.
Full-size breadboard fits. So you can.
So good for a bigger project when you need a lot of space. You want to like mount buttons and stuff to it.
Next up, we're going to just go through these quick too. We have a bunch of colors of these LED wire lights. They're actually very pretty. So here's a bunch of photos, and I'll go through these before I go to the overhead. So you can see all different colors. They wrap around things really nicely. Becky did some photos of things that you can do with the stuff, and we'll show a video in a second. But let's go to the overhead. Okay. So you can show.
Yeah, turn off the lights. So this is the wire lights, and I'll show them in detail. We want these batteries in. So it uses 2 coin cells, and these are pretty common CR2032 coin cells. And the holder is translucent, so you can kind of hide it very easily. And then there's an on switch, and so there's these really bright LEDs. And the neat thing about them is the LEDs they're bonded onto a wire. So they're flexible and small, and so you can like do costuming or a project where you want to add lighting but have it be very subtle. Like when it's actually attached, you can barely see the wire itself. Like there's this very thin wire that connects them. Yeah. And it's magnet wire, so it's even waterproof.
Super bright for a coin cell too. I mean, those are pretty nice.
They're actually. I said like make sure they're at least 1,000 millicandela LED, and they said okay. So when they made these, they made sure they were pretty bright, and so we have them in a bunch of different colors. And to solder them, you have to scratch off the coating from the silver wire. Or you can just cut the wire off here where they attach the battery holder.
And we have a video for Becky. That means we can have another drink.
Drink break.
Okay, here we go.
At Adafruit, we now have these really neat strands of LEDs on a super flexible wire. And they're powered by 2 coin cell batteries, which means you can put them basically anywhere. We have them in 5 colors, including warm and cool white. And inside the battery holder, the batteries lay side by side, so it has a super low profile and even includes its own on-off switch. Here are some of the things I tried with these LED strands. You can coil them up and put them inside a balloon, and I even left the battery holder outside so I could turn it on and off. I think this will look really nice at a wedding in a big bunch of illuminated balloons. They're perfect for wearable applications because the wire is really stiff yet flexible, so it holds its shape when you wrap it around things like this headband. And I couldn't resist adding them to Olive's collar to see her glow at night on our walks. If you want to show us your LED project, come to our weekly show and tell Saturday nights on Google Plus at 9:30 Eastern Time. They're also archived to YouTube, so you can catch all of them in the playlist right here and learn how to get on the show and tell yourself. And see you next time. Don't forget to subscribe.
All right.
Okay.
Another great video from Becky.
Thanks, Becky.
Okay, and moving on, this is kind of there's two stars of the show, I would say, besides you and Kate. There's these, and Becky tuning in virtually.
Yeah.
So three. But this is the bicolor LED matrix. So I'm kind of excited about this because
this is the third matrix. So we had the mini 8x8s, we had the 7 segments, and then finally, because the chip can handle up to 8x16 LEDs, I was like, well, this is a perfect match for our bicolor matrix that we carry, which is a really beautiful matrix with these lovely square pixels, super bright, and just like a perfect little display. But the problem with the display is, of course, it needs 24 pins to control it, and that's like a real pain in the ass. So what was nice is that by using this chip, you can control the entire matrix. You can actually control 8 of these at a time on one I2C bus using very basic commands. And so I have a little demo program running.
All right, let's go to the overhead.
And we can show it on the overhead.
Yeah.
So I have it scrolling some text. It's flashing because it's the refresh rate. It's not actually flashing in real life. But you can see it's got these nice big pixels, and it can do green, orange, red, and then the orange color is what happens when you light up the red and the green at the same time. So some people are like, well, wait, it's bicolor, but then your photo has 3 colors. That's because when you turn the red and green on, it turns like this orangish yellow color. So it's really easy to use. The nice thing is that, like, you just basically say draw pixel or draw word, text, and the text gets drawn. You can draw bitmaps and stuff. The thing about the display that you can't do is you can't mix the colors. So what I mean by that is you can turn on red and green, but you can't do any PWM mixing. Like, you can't say, oh, I want like a reddish orange or like a green that's slightly yellow tinted, because the board can't do PWM per pixel or even per color. It can only do it for the entire display at once. You can dim the entire display, or you can basically turn off or on and off certain LEDs. So I still think that, like, despite that, it's still really handy. For something, a display like this, maybe 3 colors is plenty for you. And again, it's really easy to use. So I think this is like basically this solution to, because people are asking, how do I use this display? Because it needs 24 pins.
Couple quick questions. Is a 3-color version possible or in the works? Technically, this is 3 colors.
If you want to use a tricolor board, I actually did spec out getting matrices that are tricolor. The deal with the tricolor displays is now you're talking like just a massive number of pins, and the only really fun thing you can do with them anyways is you want to have color mixing. If you have 3 colors, you can do all colors, because you can mix them together to make everything from white to teal to yellow to green to blue to pink. So if you're going to do that, I looked into it and I was like, you know what? It's actually so expensive to make a backpack for that, because you have to have it. There has to be PWM per pixel. That you're better off actually just using the RGB matrix displays we have in the store that are 16 by 24. They're quite big, but you can get a 16 by 32, 512 LED, a tricolor LED display for $80, and it has all the driver circuitry on the back, and you can use it with an Arduino fairly easily. Honestly, like, that's kind of what I ended up going towards, because for the price and everything, it was such a good deal just to use one of those panel displays.
We're going to keep moving because we were running out of time, but we got another awesome new product. This, I've not seen anywhere. This is awesome. This is a current sensor.
This is a current sensor, and this is what I think of as like a really good current sensor too. So we have a current sensing panel mount meter, and it's really handy because it has a little LED display, and it'll tell you like how many amps you're drawing. But one thing about it is it's not very precise. It only does like 10 milliamps resolution. And the second thing about it is it's only good for low side current sensing. So, oh wait, where's my marker?
Oh, do you need a?
I need a non-permanent marker unless you want me to use this. Here, I'll use this.
No, I'll grab it. But you
So
can,
the problem with
you want to write with that? Okay.
the problem with most current sensing, the cheap way to do current sensing, is like you have your power supply here, and then you have your project here, which we're going to call the load, and then it's connected to ground. So the problem is for the most part, if you want to measure your project and you want to measure the amount of current going through here, the only really easy way to do that is to put a resistor between the load and ground. So this is like a 0.1 ohm resistor, and then you measure the voltage here. And then if you multiply the voltage, knowing the resistance and the voltage, that means V equals IR. You know what the current is. The problem is that a lot of times if you have a load and let's say this load is connected to some other thing that can be connected to ground, or there's some sensors or something connected here that somehow connect to ground, it can start not working so well. For example, the Tweetawatt project, one of the things that we had to do with the XB is the reason that we have to use an XB for wireless is because the ground in the kilowatt is not really ground because it uses this technique. And so if you connect it to another project externally to measure, the grounds get connected, and then the kilowatt starts freaking out because ground is not a true ground. It's this fake ground because there's a little bit of a voltage drop here. So another, what's preferable to do when you want to measure is connect your load directly to ground again, and then you put your resistor up here, and then this goes from the positive voltage. You measure your voltage here, and then it's the same 0.1 ohm resistor, and you can measure what the current is. And this is called high side because you're at the top side, the positive voltage side, instead of the low side, which is down by ground. So this is a lot better because first off, your grounds aren't moving around, which is better for everybody. Nobody likes it when their ground reference is moving, depending on how much current. The problem is that this is a lot harder to do because let's say you're powering something off of 12 volts. Well, that means you have to have an op amp or something that can measure, or if you're measuring off of a microcontroller or something, it has to measure something off 12 volts. So you have to measure this difference voltage, and it might be higher than your power voltage. You have to have an op amp that's rail to rail, and then you have to do a lot of manipulation. It's a lot harder when you're referencing a power supply because you're taking a difference, because you don't necessarily know what this voltage is. This also might move up and down. It's a little bit tougher because you want to get this differential voltage here. So basically that's where this sensor board comes in, because it's designed specifically for high side current sensing. So there's a connector here, and you put this board between your high side and your load, and it's digital, so you connect to it with I2C, and it has a load resistor built in, this big chunk here, which is a 0.1 ohm 2 watt surface mount resistor. And so your load can be referenced to ground and everybody's happy over here. It can measure up to 26 volts DC, so even if your microcontroller system, you're trying to measure motor voltage, and so the motor voltage is much higher than 5 volts, you can still measure it without having to worry about getting an op amp that can handle this high voltage and then moving it up and down and manipulating it. And it's very precise. It's got 1% precision. And the other really cool thing is because it's connected to the high side, it will also report back what the voltage is. So you'll know both what the system voltage is and the current. So that can help you, especially if you're doing stuff with solar panels, instead of using 2 multimeters, one to measure the panel voltage and another one to measure the panel current, which is what I did when I was doing a lot
I remember we had to do that when we were testing our solar stuff.
Yeah, so you have a lot of multimeters involved. It's kind of a pain in the ass. This will actually do everything all at once, and it'll report it to you very, very quickly. So I really like it. It's really easy to use. You can use it with 3 or 5 volt systems. I saw this on a mailing list, and I was like, that is a really nice chip. I'd really like that, because if I'm ever going to do stuff with current sensing, I'd rather use this than grab a multimeter and then you're watching the multimeter and you're trying to track what's the maximum current, and you want to log the data. Now it's really hard, and now you have to get an Arduino involved. And I did, but it was there's a lot of annoying op amp wiring involved, whereas I could have just spliced a wire, shoved this in, connected up to the 2 expert C pins, and like you're done. It's super nice.
And you're selling these for like $9.95?
Oh, I don't remember what the price is.
It's $9.95.
Okay, yeah, it could be. And check the webpage.
And it's on sale in the store.
It's on sale? Yeah, it's at 10% off.
Yeah.
So if you ever have a project where you have to like measure your current draw, and you want to also track your voltage, this is awesome. This chip is great. It'll kind of solve all your problems. It only does DC voltage, so it's not good for mains current. You can't put this into your wall. It's not good for 120 volts.
How is this different than Dave's microcurrent, by the way?
The microcurrent is an op-amp based solution. It doesn't give you a digital readout, and also doesn't give you the voltage. It only gives you an analog amplification, basically. So you can still use your multimeter.
Okay.
That's a multimeter assistant.
All right. That's the end of new products. Whew, you got through it.
Okay, great.
Okay, we did an interview. We had all those things, and now we're back on the show. So we're going to do It's Not Out Yet, Don't Ask. I have a quick one. I might try to do 2. Here it is. It's Not Out Yet, Don't Ask. We got permission from the Raspberry Pi Foundation to make a Raspberry Pi badge.
And that's the badge.
And that's the badge. This is the first one off. It's called the Sew Out.
Yeah.
And it's beautiful. Look at it.
It's like Lane's PCB, but it's like Lane's badge. It's like that's the first one.
Yeah. And so now what I'm going to try to do is there's a way on Ustream here that I can actually show a window that's on my desktop. And if I can do this...
what's going to happen?
Well, if I could do this, it'll be really neat.
It's been a while since you tried this out.
This is the first time I've tried to do this recently because it's very hard to do. So if it works out, I'm going to show everybody just a quick preview of something that's going on here. So I think, let's just see if it's actually... Okay, it is. All right. So this isn't public. In fact, right now, the only thing, if you look at our Adafruit LED backpack tutorial that you'll see is this one. What I'm showing you is some of the behind-the-scenes things. And one of the neat things about this is I'm going to resize my browser here. And you notice how
the images resizes.
Perfectly. And if you're on a mobile device, like an iPad or an iPhone or any HTML thing or an Android, you'll be able to see this great tutorial from you. And we've been working on this for a while. Justin and Tyler, a couple of the new people who joined Adafruit, are helping us, and they're building out what we think is going to be one of the best systems in the world to learn.
You just like this thing.
I'm just going to do this all day.
The shifter arounder?
Yeah, and...
Do you want me to show a little bit of how to like add text and stuff?
Nope.
Okay.
And this is just a little preview. No one can get to these. We're working hard. We have hundreds of tutorials online, and our tutorials will all be part of this.
I've written all the tutorials. I've written like 130 or something tutorials, and they're all on in Dreamweaver, which has been not bad. But the problem is that then we have to turn them into a wiki page. That takes a really long time, and then like we're dependent on this wiki, and like the wiki kind of sucks, and like it's a wiki, right? And it's not fast. Like uploading images really sucks, and like doing video sucks, and so like basically like we got to the point where we're like, well, we can't do stuff that we want to do, like for example like generate a PDF or something automatically.
So the best looking PDFs to print out for your classrooms, for everything we have,
and it'll be auto generated. So for example like Arduino like changes a lot. Like there's a Leonardo now, and there's going to be a Duo eventually, and there's going to be like all my tutorials, like they're not static. Like I'm constantly editing them, updating them, improving them. People find like a bug or a typo, and like I go in and I fix it. And so the thing is, I wanted to make a system that was dynamic, so that I could write a tutorial and then adapt it later, like the wiki, but not have to deal with a wiki.
So we're not answering questions about this because we're working
on it.
It's not out yet. Don't ask.
Don't ask.
But our goal is to have the best learning system. It's called the Adafruit Learning System. It's part of Adafruit Learning Technologies, and it's we hope it's going to be the best system and learning online to maximize human potential, to share electronics, to do amazing stuff. And you'll see a lot of stuff very soon. We'll show previews as we can. The backpack tutorial is one that we've pushed out.
That's the first one.
And try it on an iPhone and an iPad
Yeah, try
and
it
an
out
Android
and
tablet.
tell us how it works.
And you'll notice every day something new on our site.
We'll try to adapt the new one every day.
We're very excited about
That still
this.
means it's a half year away from finishing.
And I'll say one other thing. I've been working on finding the best tutorial system in the world, and ultimately it was one that Justin and Tyler and you and Daigo are building.
Yeah.
I've tried them all. I've used them all. I've tried to convince companies on what they need to do to make the best tutorial system in the world, and turns out we're the only ones who. That's what we do.
Well,
that's what we care about. We needed it for us.
It's interesting because like there's DocuWiki and there's what's the Drupal, and these are all pretty good content management systems. But I don't want a content management system. I want a tutorial system.
That's right.
And that's a different thing because the way we designed it was to it's actually more like a blogging platform that's instead of a blog you're making a specific page, and so we have built-in elements like side-by-side images, sort of you know the technique that I used and then Instructable started using, and then like Vizuki also uses. So stuff like side-by-sides or images, and having the images resize perfectly so I don't have to, because like I spend half of my time resizing images in ImageReady.
Yeah. Wouldn't it be great to just toss an image in, say the licensing, and it takes care of all it for you?
It takes care of all of it for you.
Wouldn't that be a great thing?
That'd be great.
And so the best part about this is when we talked with Justin and Tyler and Daigo and our team here, we all said, we have one customer for this, Lady Ada.
That's me.
And so this tutorial
Engineer.
system is built for you, who I think is you're the most prolific tutorial writer for electronics, and this is built specifically for you. You're the customer.
I write a lot of tutorials, so
Yeah.
anything that I mean, it's true, like half of my time in tutorials is just built like editing.
You spend more doing documentation than engineering.
Yeah, but most of my documentation time is resizing and renaming images and uploading them and adjusting them and like editing wikis and editing ACLs on wikis, and I just was kind of tired of it. And so this is really exciting. And then it was like, okay, well now we have to make this all work under an iPhone, and I was like, oh man, I gotta start over. So it was really exciting. That's why our site was down, because we had to upgrade, and this is all rewritten in Ruby on Rails, which is really awesome because a lot of our development has been in PHP, and Rails is just like so fantastic compared to PHP.
Yeah.
I mean, PHP has its place. There's like nothing wrong with PHP. It's really good for what it does. But like if you want to do fast development, nothing is faster than doing Ruby and Rails.
It's future for a lot of things, and we think online learning is where it's at. You don't scale well. You can't travel the world and teach a workshop to everybody, but you can put the best tutorials online. You can do an online show. You can do online videos. You can put your designs out there. You can do all this stuff. So this is a way not only to maximize the human potential, but maximize the Lady Ada potential. All right, so that's the end of It's Not Out Yet, Don't Ask. And if you want to see the one that we just put out in the world, you can. Here's a screenshot of it that we had earlier in the show.
Yeah, go to the back, one of the
Play
LED
around with
backpacks.
it. That's the only one we pushed out. There's a lot of ones that are private.
Learn.adafruit.com?
Learn.adafruit.com is one way to get to it. All right, we are down to the wire. We have 1 minute left.
Oh, man.
Interview, new products. Don't know, it's not us.
Well, yeah, because we weren't sure Kate was going to show up, and then we had a lot of new products, so.
Okay. All right, it's time to do a trivia question.
I thought you were gonna go ask like a quote, like a any Ask Engineer
We
question.
could try. We're not going to Burning Man this year. Sorry.
I can't go to Burning Man anymore.
Yeah.
I went 5 years in a row.
Any ideas
so.
of things to do with a used computer display equipped with a VGA cable? Plug it into a.
VGA cable. Something with a VGA, you can drive with a microcontroller and a couple of resistors.
We can run a couple seconds over. All right. Anyways.
We had so much stuff going on.
Yeah.
I totally beat this week, and I have 6 more designs I'm getting sent out for fab right now.
You're on a roll. You're on a roll.
Yeah, there's a package every single day with new PCBs coming in.
Yeah, and a little update. We're still moving rapidly on getting our new space. I'm having a little bit of a meltdown because I'm trying to get architects and lawyers and all this stuff going on just so you can do engineering. So you're in your stride. I'm going to be recovering soon. I will be strong.
Okay.
Anyways, but
what's cool is we have 600 amps of power in this new place.
We're going to have 600 amps of power.
Tesla
Can you imagine us with that much?
Well, so we're constantly blowing the fuse here because it's summer, so everyone's running their AC. So we turn on the compressor and then everything goes.
Yeah, we have to put things on a different circuit. Okay. Let's
All right, let's give away some stuff.
Let's give away something here.
I think we should give
Trivia
away
question. We're gonna give away the
LED backpack.
the bicolor
LED backpack.
LED backpack. Okay.
Yeah. So you get LED display plus
Here it
backpack.
is.
Awesome.
So the code tonight was Turing, and I know everyone probably thinks I'm gonna do a Turing question, but I'm not. There's someone else who shares a birthday with Alan Turing,
What?
and he is often known as the father of the internet. What is his name?
I know this
Type
one.
it in the chat.
I know this one.
All right. Fat Geek 1.
Okay.
Fat Geek 1, Fat Geek 1. It is Vincent G. Surf. He's 69 years old today. Happy birthday,
Mint Surf.
Vint Surf. Middle name is Gray, by the way. In 1974, he said Internet. It was called the Specification of Internet Transmission Control Program. It was mentioned in a networking working group, Electronic Text, 1974. Fat Geek 1, send an email to support@adafruit.com and you get one of these.
Hello.
All right. Poof.
Awesome. Well,
Okay.
that was a massive show.
That was a massive show.
But look at all the cool things we showed off.
We showed a lot of stuff.
And I taught people about low side versus high side
And we had,
processing.
that was a fantastic segment, by the way. Everyone really liked it.
I know we have to do more of these, but it's like
Yeah.
we can only do 1 hour show, and
Yeah.
we want to show everything.
All right. Can you show the backpack
Yeah.
on the overhead just for a moment? And I'm going to do the animal handling part of
Okay. So I'll show this scrolling thing, and then I'll show backpack. Where's the matrix? Oh, here it is. So yeah, this is the matrix, and so this guy has two sets of 12 pins. Too many pins. Too many pins. So now, with this backpack and this handy chip that does all the work, you only need 2 pins. Power ground and I2C data, I2C clock. Awesome.
Okay.
Now
Oh, you know what I
that-
didn't do in the beginning of the show?
What?
I had this new thing where when you show MOSFET, it actually meows. So meow, meow, meow. But
Really?
yeah,
Now?
yeah, but you can't hear it because I have the sound off.
Oh,
Anyways, here he is.
Wait, so can you play that sound while he's here?
No.
No, you can only do it when the image is up?
Yeah. Sometimes it meows when we put him near the camera. But not today. Okay. Oh, look, he meowed.
Yeah.
That's
That
super
was
cute.
kind of a weird meow. He's usually much more vocal, but I think he's kind of weirded out.
He gets scared.
I mean, you must admit, if you held me up in front of a gigantic camera, I would also probably be a little freaked out.
You do freak out when we hold up a gigantic camera.
Anyways.
It's true. All right.
All right.
Okay. Thank you, Becky, for stopping by. George for doing the recording. Paint Your Dragon stopped by tonight. Phil Burgess. Special thanks to Justin, Tyler, and Daigo, who've been working around the clock on the secret thing that we showed. That's now not so secret anymore.
Yeah.
Special thanks to Kate
It's in
Hartman.
alpha still.
Yeah, special thanks to Kate Hartman, who came out and did a fantastic interview. She was the one who does the botanicals and lots of other stuff at katehartman.com.
Yes.
We will have some awesome new products to talk about next week. I believe Amanda Wozniak is coming up on the show this Saturday.
That's right, next week.
So we're exhausted. We're going to go to sleep now. But thank you, everyone. Here is your moment of Zener.